Hello, everyone. I believe you are all doing well. I welcome you all to another lecture series on the indices and logarithm. I want you to know that this is a pre-recorded session. So at any point in time, if you have any question, you might have to write it down. Then you send it to me in my private inbox and I'll address that. As we always do, the session will also be uploaded on your channel. So if there is a part you didn't catch that, just know that it will be recorded. The recording will be uploaded and you can access that anytime, any day from the comfort of your home by using your handset. In our previous session, we looked at the properties of the laws of logarithm, and I gave you some practical examples to which we tried together. So today, the other examples I want us to be looking at together. So let's begin. Sorry. So we have, I need you to simplify. That's a preamble. What do we have here? So log 6 minus log 2. 2 log 3. So for these examples, we'll just be applying the laws and some properties. After writing the question, we'll look at the properties first before tackling this. 2 minus 2 log 5. Half log 9 plus 1. This we solved that a while back in our previous session. Half log 25 minus 2 log 3 plus 2 log 6. Then I log 9 log 9 on log 3. Then I log x plus 1 minus log x squared minus 1. Ix 2 log 5 base a plus log 4 base a minus 2 log 10 base in. Now, to begin, I want us to look at a few properties I'm yet I never discussed in our previous session, but I feel will be useful here. Let me allow you a few minutes to finish writing before we start. We have 2 minutes. All right, 2 minutes is up. So let's start with um properties of logarithm. Okay, before we can continue solving these questions, at some point it will be useful. So properties of logarithm. So aside the laws we all learn together, we use that with the properties in solving questions in logarithm. And the properties are just a few. So we have property 1 and property 2. Okay, now property 1. So if you have the log of a number to the base of the same number, the answer is simply 1. Don't write log, don't attach log to it. So when you have the log of patience, okay, raised to the base of patience, as long as the number in the base is the same, look, the answer is automatically 1. Now, you can put this into numerical form. So in the same vein, if you have the log of 5 to the base of 5, as long as the number and the base are same numbers, the answer is 1. And you can put that on your calculator. So you can punch the log of 200 to the base of 200 is what? 1. You know there is this feature on your calculator that allows you to punch log with a base, right? This feature, look for it. So if you get that, you just put 5 here, and then you shift the cursor and put 5 here, and you check the result. It's going to be what? 1. Now, I want you to take note of this property, okay? It's going to be very useful. Going forward, we'll be using that to solve some questions. We'll be using this idea to solve some questions. Take note of that, okay? Because to get one, you've come to understand that to get one, just have the log of any number raise express on the base of the same number and you will get one. It will help you going forward with some questions. I'll not bring it up here, but watch out. Then the last property I wanted you to know, because I know, is property 2, which says when you have the log of a number, okay, raised to the, sorry, when you have the log of 1 raised to a base, okay, is nothing, which is 0. When you have the log of 1 to any base is what? 0. This will take note of that. Log 1 to any base, log 1 to any base is 0. So log 1 to the base of z, 0. So log 1 to the base of 200 or 9,000 is what? 0. Take note of that. Now, if this has sunk well, we can proceed to dealing with the questions above. Okay, I believe you're done writing. So now, in our previous session, I solved a similar question like this with you, so I'm not going to solve that. Question number I. So I'm allowing you 3 minutes. Try that and listen. I want you to be sincere with yourself. You do that, we do it together. You compare the answers. You see the step which was flawed. You correct yourself. This is the only way you become good at mathematics. But if you don't do it, you just spectate. Math, it's not studied by just observing. You observe and do. I keep saying math is not like any other subject. You observe and you do it. By doing it, it sticks. All right, I may not stick to the 3 minutes. So log 6 minus log 2. That was the question. Now to solve this, in our previous session, I told you when you have the log of a number, subtracting the log of another number, and both logs are of the same base. This is why I emphasize that there's a base. I told you when it has a base of 10, we don't write it. So if you have the log of a number expressed on a base and is subtracting the log of another number on the same base, You see, the base here is what, 10, right? When it's 10, we often don't write that. So you see, just write one log, express that log on the common base, okay, which is 10. I will not write that. Then if they are subtracting, divide the numbers involved. So you have 6 minus 6 divided by 2. Now, in the end, you have the log of what? 3. And that is it. That's the final answer. Hopefully, that's what you had. And you can key these on your calculator. Since the base was avoided, use this log feature on the calculator log box. This. It's assumed the base is 10. Use that. Okay, so let's look at the next one. The next question. I. Yeah, there's two. You have 2 minutes. I solve a similar question like that with you. You have 2 minutes. 2 log 3 plus log 2. 2 log 3 plus log 2. In case you're looking for the question, 2 log 3 plus log 2. This. Again, it's a pre-recorded session, so if you ask any question, it's not a live session. I can be available to respond right away. So if you have any question, you can just write it somewhere, or in the course of the session, you can just write your query to me, and I can address it for you. Yeah, via WhatsApp. So if you're doing this very well, um, if you remember the law three, which talks about a number raised to, when you have a number raised to a certain power, the power is reversed to the front, right? So this look like one which had a power then and it was reversed. So you can just, so it's going to be log what? 3 squared. So you bring it back because you bring this back because if it's there and you are asked to simplify, you will bring it back. But now we needed to solve the whole question. So that is it. Then plus log what? 2. Then now, log 3 squared is 9. So plus log what? 2. So you have log, remember when this, now you refer to law 1 or law 2, one of them which has to do with addition. It says when you have the log of a number with a base, adding to the log of another number, but with the same base, both log have the same base, which is 10. It's usually base 10 we don't write. So we have the log of a number to a base, adding up to the log of another number to the same base, and they are adding, multiply. So that would be 9 times what? Multiply the numbers involved. We said that, and you express it on the same base, which is 10. I'll choose not to write because it wasn't written in the question. That is not to see if you write it is wrong. So that'll be log 27. Okay, wait. I was just trying to cross check. The numbers involved is 9 times 2. Yeah, it's 2, not 3. So that'll be 18. Yeah, 18. Sorry about that. All right, let's move on. Sorry for my long pause. I needed to see what's going on. Um, so let's go to the third one. I. That I will solve with you. Let me. I'll write the question and I'll allow you to finish writing. 2 minus 2 log 5. Yeah. So there's a log. This is what the log language is about. So if you have any question in the decimal form and you have to solve and you can't solve by using a concept, if the base are the same, if the bases are the same, you equate the powers. You try to convert them to logarithmic form and you apply these rules and properties. So what we're doing right now is getting used to the laws and the properties, okay? And in exam, of course, they will ask you general questions that sort to analyze how you think around the laws and the properties. If you're good enough, okay. So 2 minus 2 log 5. So now, if you study this question, the first part doesn't have a log, and you can only solve when it has a log. Then you analyze the bases to see, oh, the bases are the same. So let me what? And the bases are the same. So let me see the sign between the subtract and I will divide. It doesn't have a log. So would you say you cannot proceed to solve? Well, not yet. So this is where the properties I taught you comes in. Okay. I want us to apply one of the properties to see. Okay, one of the properties to see, then we take it out from there. Okay. So do you remember this property? I said property one, I said when you have the log of a number raised to the base of the same number, it's one. It's one, right? It's one. Okay. Then can we hold on to our two? Okay. And let's write the log of a number. I can use 2 and raise to the base of 2. After all, it's 1, my dear. But I don't want to use base 2. Here, the base is 10. Okay. I want to do something to be common for all. Okay. So since the base is 10, let's do log 10. When you have the log of 10 to the base, there is no base, but it's assumed the base was 10, right? When there is no base, it's base 10. When you have the log of 10 to the base of 10, it's 1, right? Which means this, it's more like 2 times 1 is 2. So I have not changed the question. I'm doing some manipulation which will help me eventually, right? Mm-hmm. So to solve that, I choose to express it on the same base. Okay, then minus, let's continue. So you have 2 log what? 5. And this thing I'm doing, you can put 2 minus 2 log 5 on your calculator and check the answer, have it down. We'll arrive at the same answer. Hmm? Okay. Now, if you progress, now you can apply your thing. You have log on the left side, you have log on the right side. So you can apply your thing. Of course, you do or you move the two right. So it will be like that. You just did one not long ago. So this one too will be log what? 5. You move the two. Then that will be equal to log. That's 10 squared is 100, right? Then you have minus log 5 squared is 25. So now you have the log of base 10, okay, minus another log of base 10. So the bases are the same. So you pick one log. When they are subtracting, you divide the numbers involved. That will be 100 on what? 25. If you don't meet your quail with your paper and start doing it, uh, doing it, this will be a new thing to you in exam. So that will be equal to log 100 on 25 is what? Is it 4? Yeah, that will be log what? 4. So generally, if you have one log on a side, okay, and I mean, you the the other side doesn't have a log. You have to solve it strategically. And one of the strategies is what I've shown you. Check the properties. One of them can save you. Okay. I'll allow you to write. Then we move on to the next. One second. I just want to look at the next question. Okay. You can continue to write. So the next question is half log 9 plus 1. It's similar. So I'm giving you I'm giving you 2 to 3 minutes. Solve this yourself. Okay, so it's time. Let's see what we have here. So you see one portion has a log, another portion doesn't have a log. So to solve, let's express the other portion in logarithmic form without changing the question. I'll apply one of the properties. U1 be here. I know when I have the log of a number to the base of the same number is 1. Since the base being discussed here is 10, okay, I would write log 10 so that log 10 to the base of 10 is 1. So this whole thing is 1. So it becomes 1 times 1, which is 1. So the question was plus 1. I've not changed anything, it's still plus 1. That log 10 base 10 is just a symbolism. In literal sense, it's 1. If you solve log 10 base 10, it's 1. So 1 times 1 is still 1. Do not put something there if that thing changes the question or yield another number, then that makes it wrong. In math, if you're doing manipulation, it might bring you back to the same thing, not change it. Okay. All right. So it's equal to, and it's right. If you can replace a number with a different form, and that form, if you solve it algebraically or mathematically, it gives you that number. Okay, it doesn't alter that. It's correct. So now having this now I can solve. So I will just have log 9, then you push the half on top, right? This is log 3. Then plus log 10. Let's clean the 10 because the base was not given. So let's avoid it. We all know it's base 10. You push the one up. If you're smart enough, you know use the one. So that'll be log. Now, if you refer to indices, 9 exponent half is the same as square root of 9. I'm not here to teach you this. Square root of 9 is 3. Refer to the lesson in indices. One of the properties, yeah, properties of indices. All right, then plus, yeah, log 10 exponent, 1 is log 10. Now you have the log of a number with the base adding to the log of another number with the same base adding. Then write log, since they all have the same base, write the same base, which is 10. Yeah. Then 3, they are adding. When they are adding, multiply the numbers involved. You only do this when the bases are the same. If you ever meet a question, the logs have different bases, do not add. It cannot be solved. Take note. Don't force it. That'll be log what? 30. Don't force it. Let's move on. So the next question, and I guess it is what you had. Hold on, I'll allow you to write. Let me see the next question. So we looked at this. We looked at, I think we looked at this. Okay, half log 25. Okay, you're right. Okay, so I believe you're down right, and I'm giving you 2 minutes to try this question. It's quite similar to what we've done. All right, so let's look at this together. So we would have, so let's look at log 25. Let's push the half up. So exponent half minus log 3 squared, right? Plus log 6 squared. So that will be equal to log 5 minus log 9 plus log 36, right? Now let's see what we have here. So this will be equal to log. So you see, they all have the same base. They all have the same base. So you can choose to just solve them together, or you can choose to solve them in bits. So if we are to solve them together, we have 5 on 9, okay? Right? Because log 5 is 10 minus log 9 base 10. They have the same base, okay? 5 on 9 times 36. Why? Because they all have the same base, and what do we call it? Um, they are adding up, right? So 5 on 9 times 36. Or if you're getting confused, well, 5 on 9, then plus log 36. When we are done, we'll look at that. So that'll be 5 on 9 um, times 36, right? Because now they have the same base and they are adding up. At the end, we have in log. So 9 into itself is 1, 9 to 36 is 4, so it will be 5 times 4, which is what, 20. Yeah, simple like that. Okay, so I will allow you to write and we look at the next one. Allow me to check on the next question before. If you're done, okay, log 9 over log 3. Okay, right. You can proceed to write. And this, we solve something similar, so I'm allowing you 2 minutes to try that. Okay, so let's see. Um, so with this, last time that was the last kind of question we solved in our lesson. Yeah, the very last lesson we had. 1 second. Right, so we should have log 3 squared. Because you can't just cancel the 3 and the 9. I warned you about that. They are not alone, they are with a log. So the best is to go this way, like something that you can carry the log with it when you are canceling. Okay, so on log 3. So you would have log sorry, you bring the 2 behind, you have 2 log 3 on log 3, which will be equal to, this one cancels that. You see, when it happens like this, now log 3 cancels log 3, and you have what, 2. We did this in our previous class, so it shouldn't be a problem at all. Hmm? Let's move on. Now, the next one. So we've looked at this. Sorry, let me use the red mark. So we've looked at this. We've looked at this. Let's look at the V I I log x plus 1. Let me allow you to finish writing this. Yeah. We have log x plus 1 minus log s squared minus 1. I believe by now you're done writing. So let's look at this question. With this question, you will need a little idea in algebraic expression to be able to tackle that effectively. So you have log x plus 1. Of course, base 10. The other log 2 is base 10. They're subtracting, so you can divide, okay? But let's look at this. You divide, so that will be divided by log what? No, sorry, divided by no log x squared minus 1. Okay, now learn this once and for all, because we'll one day meet it. X plus 1. Now, in algebraic expression, there is something called difference of two squares. Let me write it in. Difference of two squares. Difference of two squares. Difference means subtraction. Our emphasis is on this, s squared minus 1. Difference means subtraction. Two squares means two terms with power 2. Okay, so this one must be on power 2, but we'll talk about that. This is how it works. When you have a term squared minus another term squared. Okay, so this is difference minus, right? Difference of two terms squared, right? And I have difference of two squares. What happened? It says write the first term, put plus in between, drop the second term, repeat the same thing, but change the sign. So if you have a difference of two squares, so this is a simplification. Learn that once and for all. If you like, expand this bracket and simplify. It will bring you back to this. It will bring you back to a squared minus b squared. Now, so when we have this knowledge, anytime I see a square, okay, I'm like a magnet. Anytime I see difference of a square, even if the other one doesn't have a square, I just get attracted to it, okay? I mean, that's why I place my thinking on until it's not workable. So you see, s squared minus 1, I can express 1 as squared because 1 squared is 1. So s squared minus 1 can be rewritten as what? S squared minus what? 1 squared. Remember, if it's S squared minus 2, you can't do the same for 2 and say, oh, there is a difference. There is a square, so 2, let me make it squared. You can't make it squared. 2 squared is 4. You've changed the question. Do you understand? If I give you S squared minus 2, you can't make the 2 squared. 2 squared is 4. And the question is S squared minus 2. Yeah, the question is S squared minus 1. I can make 1 squared because 1 squared is still 1. I have not changed the question. So it depends on the situation. Sometimes you just get S squared minus 2 squared. You know, right? You know the simplification. It will be x plus 2, 1 bracket, x minus 2. So for x squared minus 1 squared, it's what? X plus 1, x minus 1. Difference of 2 squares as a simplification. Yeah, so I would like to continue on top because some people might be right. So I'll continue here. And when you do that, x plus 1 cancels that. You see? So in the end, what are you having? You're having log. Don't forget this. 1, because x plus 1 gets into itself 1 time. So log 1 over what? X minus 1. Hmm? So we have to continue. That's x 1 over x minus 1 is the same as x minus 1 exponent what? Negative 1. Do you remember? So back to indices. 1 over x minus 1 can be the same as x minus 1 exponent negative 1. X minus 1 exponent negative 1 is the same as 1 over x minus 1. If you remember, refer to indices. Hmm? It's about negative index. Negative index. Hmm? When you have a number raised to a negative index, it's equal to the reciprocal of that number raised to the same but positive index. Yeah. So that will be equal to, yeah, so I can simplify this. Now, this you refer back to logarithm, right? The last law, which is the third law, you can bring the negative first, negative 1 log what? Oops. Yeah, log x minus 1, right? Which is equal to negative log x minus 1. You get it? So that is it. That's a simplification. I believe you're learning a lot, and it's for a reason I'm actually trying to solve all of these for you. It's for a reason I'm trying to solve all of these for you because I'm going to give you another set of example and any kind of question around that. You see that, oh, I've seen this before. You see that you've seen it before because I've given you series of that. Yeah. 1 second, I'll allow you to go through. I just want to see what's next. What's the next question? Oh, I'm done. Oops. Let's see. Oh, 2 log 5 BC. Okay. So continue writing. Continue writing. Two log 5. Yeah. BC plus log 4 base A, keep writing, minus 2 log 10 base E. Yeah. So this is similar to what we did earlier. I'll give you 2 minutes to, to work your way around it first before we try that. This is the last example. How is it going? So, yeah, in our previous example, we push the two up like that, right? Then plus log 4 base A, that it's cool, minus log 10, you push the two up, right? Then now that'll be log 25 base A plus log 4 base A minus log 100 base A. Then you can solve them one after the other. Log 25, right? Base A. Remember, 4 is also expressed on the same base. So since they are adding, I'll multiply. So times 4. Then minus log. If it was me, I'll do it together, but you can choose to do it in bits. So I'll have log 25 times 4, I think it's 100. Yeah. Base E minus log 100 what? Base E. Right? What happens? Oh, the same base, they are subtracting. So what happens? That'll be log what? The same base. Then you divide because they are subtracting 100 over what? 100, right? That'll be equal to log to the base of 100 over 100 is what? To 1, right? You have to do the right thing. That will be equal to log what? Log of 1 to any base I told you is what? 0. Hey, sorry, did I say log 0? I'm sorry. When you have the log of a number to any base is 0 without a log. Sorry. So that is it. You see, the rules of log never fails because at this point, I'm sure any brilliant student might have seen that log 100 base a minus log and then is 0. At this point, anyone very observant might have said is 0, right? But follow the right procedure and you notice that it will come out by itself easily. So this confirms that the rules never change. I'm sorry, this confirms that the rules and properties are proper. So guys, this is a first set of examples. There are a lot more. So I'm going to give you some as an assignment. Then we'll solve a different series of questions. Different kinds of questions you're also likely to meet in exam. Yeah. So finish writing. I believe you've gotten the opportunity to go through it as well. Okay, so let's see. Now, I will need you to practice, do this yourself. Next, that's the next series of example. So this will be our assignment. Then we can proceed to another set of questions. So your assignment, you send it to my inbox before tomorrow. No, some of you might go to work, so you send it to my inbox before our next session. Okay. Yeah, tomorrow we have an elective class. So yeah, the following day. So you have ample time. Simplify I log 12 base 5 plus log 10 base 5. Log 9 base 7. Sorry, 2 log 9 base 7 minus log 81 base 7. I log 24 base 3 24 base 3 plus log 15 base 3 minus log 10 base 3. IV log 98 base 7 minus log 30 base 7 plus log 15 base 7. Okay, so that is it. I will allow you 3 minutes to finish writing. Then we can proceed to the next set of examples. Okay, so now, so you do that and you send it to me. Now let's look at another style of questions you should expect in your exam. Yeah, so what question am I being? Okay. Yeah. So this next series, let me just write next set of questions. Now you look at this question. Given that, given that the log of 10, sorry, the log of 2 base 10 is equal to 0.3010, and the log of 3 base 10 is equal to 0.4770. Find without using tables the value of I. Well, not to contradict ourselves, let's use the value of alpha log 5 base 10 beta log 3 whole number 1 over 3 base 10. Sorry, um, pi, no, rule, sorry. Yeah, this somewhere is called rule. Log 0.4 base 10. It's been a while I tried examples like this, but we'll navigate together. Okay, finish writing and let's look at them. Okay, so while you're writing, so you may ask, so what kind of questions is this? So they know you can easily put log 5 base 10 on your calculator, okay? And you have the result and write it. But they don't want you to do that. They've given you the log of certain numbers, and they want you to find log 5 using the log of those numbers. What are those numbers? So they want you to find log 5 using log 2 base 10 or log 3 base 10. To find that, you should use these in your solution to find it. So you see this, they mention in the question, do so without using tables. As we ascend in this lesson, I will show you logarithm tables and how to use them. But they say we shouldn't use that. Use tables, or in other words, calculator. Let's see. Let's see. I believe you should be done writing by now. Now, again, all the questions we've been solving, you can key in the question on your calculator, and the final answer must be the same as what you work for. Okay, I usually advise them to do that because in exam I might not be there with you, right? So you must have something that would guide you that, hey, what I've done is right or wrong. So the calculator will give you the final answer, then you work towards that. Now, for this question, what happens? Because they've given us the log of a certain number. So what happens now? Because it looks like we have to be careful with our calculator. Now, I'm here to tell you that, first of all, find log 2 on your calculator and check if the answer is the same as what is given in the question. Find log 3 on your calculator. Check if the answer is the same as what's in the question. If the answer is the same, then it means that when you use these to investigate for log 5, log 3 whole number 1 over 3, and so on and so forth, the answer you get by solving this manually must be the same as when you put log 5 base 10 on the calculator. Let me repeat myself one more time. I said, first of all, find log 2 on the calculator and check if the answer on the calculator corresponds to this. Find log 3 on the calculator and check if the answer corresponds to this. If the answers correspond to one another, then it should tell you that when you solve log 5, when you solve log 3 whole number 1 over 3 base 10, and so on and so forth, manually, using these numbers, log 2, log 3, and stuff, the answer you get must be the same as when you put log 5 base 10 on a calculator. Yeah, 1 second. All right. Now, the next thing I want to tell you is how to solve these questions. Given the logarithm of certain numbers, how do we solve that? So for questions like these, what we do is that log 5 they've given to us, we must look for two numbers when you multiply or when they divide, they will give you 5. You don't just select any two numbers. The numbers you select must be numbers you can find 2 and 3 in them. One of them. Okay. The numbers you find must be numbers you can find 2, you can find 2 and so for log 5, so let's look at alpha. So for log 5 base 10, what numbers can we multiply to get or divide to get 5? 5 is a small number, so if you ask me, I'll go for division. Okay, 5 is very small, so I'll rather go for numbers I can divide. And that number should be numbers I should see 2 or 3 in it, you understand? So in place of log 5, you replace it with those numbers. So I'm thinking of 10 on 2. Okay, 5 is a small number, and there are no numbers you can multiply to get 5 other than 1 times 5, but I don't need it. 1 times 5 is the same as is the same thing, right? If it was a big number, I would have considered multiplication. So you see, 10 and 2 is good. Why 10? Remember the base is 10. So something can even happen to the 10. Why 2? 2, at least we see 2 here. You see log 2. So it will be useful. So that's how we play. All the time, look for numbers. When you multiply or divide, you get 5. Okay? So this becomes log to the base of 10 of what? 10, right? Divided will be my, do you remember how did we arrive at division? I mean, you see, sometimes when a question cast your mind back to the laws, when it's division, when it's subtracting, we divide, right? So reverse it. When it's subtracting, we divide. When it's adding, we multiply. So at this point, you reverse it. So you only do those reversal for this kind of question. So that'll be minus log what? To the base of 10 of 2. Okay. Then log 10 base 10, you know is 1, right? So that'll be 1 minus log 2 base 10 is referred to the question. Given that log 2 base 10 is this. So wherever you see log 2 base 10, you put 0 point what? 0 0.3010. Now, what's the answer? I prefer, so you have 1, all right, minus 0.3010. I'm referring back to GHS, junior high mathematics. So I'll make it 0.0000, okay? Now, if you are subtracting, that means what? Do you remember these things? You borrow 1 from here, so here will be 0, here will be 10, but you move it, right? You need it at the edge, at the end. So you take 1 from that. This one will be 9. Okay. The 1 is here, but you still borrow, so it will be 9. 1 joins it becomes 10. I'm borrowing here, so it will be 9. So here has become 10, but you borrow, so it will also be 9. So if you follow suit, that here will be 10. Right? So 10 minus, oh, what did I do? 0 minus 0 is 0. I'm sorry. Yeah. 0 minus 0 is 0, right? It's needed here. So 10 minus 1 is 9. 9 minus, so 9. 9 minus 3 is 6. then point 0 minus 0 is what 0. So in the end, you have what? 0.6990. So that's a result. And if you put log 5 base 10 on a calculator, you should get the same answer. All right, so let's continue. Um, so let's see the next question. So it's the same thing we're gonna apply. So I see log 3 whole number 1 over 3 base 10. Okay, that's beta, right? Log 3 whole number 1 over 3 base 10. So that'll be log of base 10. That'll be so for a question like this, you should simplify it first. If you are to simplify this, last time I was showing Abigail through number 1 over 3. I said to solve this, you multiply 3, this b's denominator to the whole number portion. That would be 9. Then you add 9 to the numerator. So 9 plus 1 will be 10. Then you express it on the base of 3 on this base. So that will be log to the base of 10 of what? 10 over 3. Well, doing this question, this is not like a whole number like 5. I will need two numbers that multiply or divide to get, 5. Okay, from how this is looking, 10 is there. 10, I know 10, 10. Something like this will happen where we'll get 1. 3, 2, they give us log 3. I think we'll end up having log 3, and log 3 was given in a question. Well, if you can't think the way I'm thinking, no worries. Just look at us while we open up. You get it better. This one belong to the base of 10 of what? 10, right? Right? Let's open up. Remember, how did we learn addition? Meaning initially they were subtracting, right? Log to the base of, it's only when they have the same base, we choose to write them on one base and we divide. So meaning you should understand why I'm expressing it on base 10. So that would be what? 3. Have we seen it? Then now this will be what? 1. Log 10 to the base of 10 is all 1 minus log 3 to the base of 10. No, log 3 to the base of 10. It's already in the question. There's a given that log 3 to the base of 10 is what? 0.4770. So you have 0.4770. Then you solve this. I prefer, look, be careful using the calculator for log, okay? Log calculations, logarithm, well, additions and subtractions in log. We'll do log algebra very soon, but be careful, be careful, be careful. It will interest you to know that in log, when it's a -2, we don't write it as this. We write it as this. And the calculator will use this function, which means the possibility of giving you wrong answers is higher. Because in log, we believe if it's a -2, it only affects just a 2. So if it should be 2.43 something, the negative should affect just a 2. So that's why you see me doing this KG style of subtraction. Okay, so 1.00. Okay, they were subtracting. So this one will be 0. Okay, and This one I have to borrow. So you know, right? Here will be 10, but I will still borrow, so it will be 9. Here will be 10, but I will still borrow, so it will be 9. Then here becomes 10. 10 minus 7 is 3. 9 minus 7, 2. Yeah, 4 minus 9 minus 4 is what? 5. 0 minus 0 is 0. So this one too, the result is what? 0.5230. If you have to put this on a calculator, If you have to put this on a calculator, you get the same. If you have to put log 3 whole number 1 over 3 base 10 on a calculator, you get this result. Right. While you write, I'm giving you 3 minutes to finish writing this, and then solve the last one, which is log 0.4 base 10. Yeah, log 0.4 base 10. You have 3 minutes. So it gets interesting as we progress, right? So something like this, I don't know how you're solving that. Okay, but 1 second, guys. Yeah, okay, I got it out. Yeah, so um with this, express the 0.4 better. 0.4 in log, 0.4, sorry, 0.4 in a fractional form. Put it on the calculator. Okay. But it's gonna be, you know, it's gonna be 4 on 10. Okay. It's 4 on 10. It's 4 on 10. If you want to reduce it further, it would be 2 on 5 or something. But it's 4 on 10. So let's start with this. If you're wondering how I had that, usually 0 points, any number, it's the number over, you know, the number over, um, the number over multiples of 10. Yeah, that's the right word. Yeah, so this one is 4 on what? 10. In 4, I can get 2, but we'll get there. So if you're resolving that, that'll be log 4 base 10 minus log what? 10 base 10. 1 second, guys. Okay, so now having this, let's see, in the question, we're given just log 2 and log 3, right? Yeah. So, we'll have, yeah. So I'm sorry, guys. I just get distracted with a message. Yeah. So we're given log 2 and log 3. So I can find 2 in 4. You know, log 4 can be rewritten as 2 squared, right? Right? Base 10. If you don't want this, okay. If you want to stick to what we've been doing earlier, you can also see log 4 is the same as what? 2 times. I said look for two numbers. When you multiply or divide, you get 4, right? So it will be 2 times or 2. Okay, base 10. It's up to you. Minus log 10 base 10 is actually 1. It's up to you. Whichever one you choose is correct. So that will be equal to log. So this one will be log to the base of 10 of what? 2, right? How did we end up multiplying? Meaning initially was log 2 plus what? Log 2. You get it base 10 minus 1. Because it's when is this way you say, well, the base are the same. So I'll pick one log base 10 2 by 2 since they are adding. And log 2 is given in the question as it's given in the question as, let's see. Let's go and copy 0.3010. 0.3010, right? So this one to 0.3010, right? Minus what? 1. So let's solve them. 0.3010, 0.3010. If you add in them, it's going to be 0206.0, correct? Now this 0.6020 minus what? 1, right? So 1.0000, right? So I'll get 0.206 point. Watch closely. 0 minus 1 is what? 0 minus 1 is what? It's negative 1. Hold on. Let me see if we did the addition well before we even move on. I think something is wrong somewhere. Guys, 1 second. Yeah. Yes. Minus log 10 base 10. Okay. Yeah. And what was given? Log 2 base 10 was 0.3010. Okay. Okay. Right. Minus, yeah, minus 1. Yeah. Oops. 1 second. What's going on? Yeah, all right. So I've seen where the problem is. You see, 0 minus 1, it's not possible, right? Because um the down is bigger than the top. So we must borrow. There is nowhere to borrow, right? So let's switch it back. You get it? So let's turn it the other way around. So it's going to be more like, so it's going to be like, watch closely. So it's going to be your negative 1. You get it? It's going to be, so more like, here is 0. Let me put it this way, 0.6020, right? Minus 1. And I want us to switch it by making a minus 1 plus what? This is already plus, so 0.60 what? 20. You get it, so that it makes sense. Then we proceed. All right, so at this point, this is what we're gonna do. Um, negative 1, okay? Of course, let's do it this way. Plus 0.6020. I mean, can be rewritten as 0.6020, right? This minus 1.000. Okay. We just have to be careful with the negative signs. Now, this from this, it's evident that 1 is bigger. Okay, 1 is bigger than this side. So let's conduct a layman subtraction. I'll prefer to write the 1 first, then 0.6020. When we are done, we'll attach the sign. Yeah, so okay, so 1.000 minus 0.6020. And let's conduct the subtraction. So what are we getting? So we have 0, 0 minus 2. Okay, so it's not working. This is 0. So um here will be 9, 9, 1. So here will be 8. This one will be 9. This one will be 3.0. You get it? Uh-huh. And now remember, the one was negative. So we bring the negative over there. So I mean the one, you see, originally was what? Negative, right? Yeah, so that makes it 0.3980. Yeah, negative. I will I will upload this session on your channel to check again. I need you to try your hands on a similar question I'll leave on a school page. So aside this I gave you, aside this, the first assignment I gave you, I'm going to send another one which is quite similar. So watch out. Um, this will be the end of today's session. Should you have any question, just feel free to leave it in my inbox. Remember to like the channel and subscribe. Have a nice day.